visible? Is it visible? Is it visible?
Yes, sir.
Okay. Okay, now last class we discussed about the disinfection. What is the disinfection? To destroy the pathogens. And in India, we are using chlorine as a disinfectant because the chlorine having the residual property, means after the treatment, the chlorine is remain in the water body in the form of residue, and that is very important for the Indian territory because in the Indian, if you see, this is the water treatment plant. If this is the water treatment plant, and you are treating the water here. After treating, you are saying the water is safe for drinking. But after that, when you distributing the water through this water distribution line, if there is leakages in the water distribution line, because in India most of the water lines are old and there are chances of leakage. So what will happen? The foreign particle, foreign bodies or microorganism likely to be enter into the water distribution line. These are the water distribution. This is water distribution line. Okay, in this water distribution line, what will happen? Through the leakages, the foreign bodies are likely to enter. So in that case, the residual chlorine is going to act as a soldier. Residual chlorine is going to act as a soldier. Once the foreign particle or foreign bodies are enter into the water body, the residual chlorine is going to act on that and kill that particular microorganism. So that's why in India we are using chlorine as a disinfectant. But as well as uh, there are some disadvantages if you consume the chlorine for the longer duration, for longer dose, there are chances of cancer. But if you, because of this reason, in the most of the developed countries, they are using as ozone as a disinfectant because their water distribution lines are leakage proof, or we can say so many sensors are installed in the water distribution line so that they can easily understand where is the leakage and how to rectify. But this feasibility, this facility is not available in our country. So we are using disinfectant as a residual chlorine. Now, how the particular disinfection takes place, that we already discussed. Now, when you add the chlorine, into the water body, what will happen? When you add the chlorine in the water body, this is your H2O. When you add the chlorine to the water body, what will happen? The reaction takes place and HOCl, the hypochlorous chlorous see hypochlorous acid is going to produce. When you add the H2O, when the chlorine is going to be added into the H2O, what will happen? The hypochlorous acid is going to produce. This hypochlorous acid is again this is a reversible reaction. It is going to be converted to the OCl ions. That is called as ionization. And OCl is what? Nothing but what? Hypochlorite ions. OCl is what? Hypochlorite ions. Now, from the point of view of disinfection, the HOCl is more effective. HOCl is near about 80 times effective than OCl. HOCl is what? 80 times effective than OCl. So our aim is to what? Maintain the HOCl concentration in the water body at highest level. Means what? If the OCl kills one microorganism, HOCl kills 80 microorganisms. So that will be shortly I'm saying that is the 80 times effective than OCl, and that is the this HOCl formation and OCl formation is depending upon the pH. What is the water? What is the pH of that water body? That will decide how much HOCl is there, how much OCl is there. Now, if you see the graph, HOCl on the y-axis, on the other y-axis OCl concentration is there, and the x-axis pH is there. And these are the two different temperature lines are there. One temperature, one is for the 20 degree, and second is for 0 degree Celsius temperature. Means what? Temperature is also parameter affecting on the formation of HOCl, OCl. But most important prime parameter is what? pH. Now, if you see the pH 6, if you see the pH 6, what will happen on the for the pH 6? You will get the How much HOCl concentration and how much OCl concentration? Anyone?
So
This is
95 and 5.
yes, HOCl concentration we are getting in between 90 to 95, and naturally remaining is what 5 means what if you add the HOCl plus OCl that comes to be 100. So this way the particular concentration of HOCl and OCl is going to works. Now which parameter is required for the disinfection? Which formation? Which HOCl is important or OCl is important for disinfection? Which is more
HOCl.
effective? HOCl is more effective. Is it okay? Similarly, if you go for the pH 9, if you go for the pH 9, how much HOCl and how much OCl?
5 and 95.
See, somewhere in between 0 to 10, and here 95 means what? This is the OCl concentration is 95 and HOCl concentration is what? 5. And HOCl is what? 5 and OCl is 95. So this indicates what? As the pH increases, the disinfection efficiency decreases. So we need to maintain the pH properly so that more disinfection is going to be possible. So this is the factor affecting on the pH and on that. Now last class also we discussed about how the breakpoint chlorination works. Breakpoint chlorination means what? See, there are 4 stages. So once you add the chlorine, if this is the water, if this is the jar, in this jar if the water is there, H2 is there, in the H2O, if you add the chlorine, what we are adding? If you add the chlorine at the start, what will happen? And add up to at the start, what will happen? That is going to be shown by this graph. Okay. Once you add the chlorine into the water body, what will happen? First step in the stage number 1, what will happen? The stage number 1, the inorganic impurities are going to be combined with the chlorine molecule. Inorganic impurities are going to be combined with the chlorine molecule and they get oxidized. That is the stage number 1. So see, first on the y-axis is what? Residual chlorine is there, and on the x-axis what? Chlorine dose is there. Chlorine added means what? How much dose we are applied. It's for example, if you are ill and if you taking the dose of 500 milligram of tablet, okay, out of the 500 milligram, how much consume, how much actually utilize? Okay, so same thing is there. If you add the chlorine 500 milligram, out of that 500 milligram, how much chlorine is going to be residual form in the water body? That we are discussing here. What will happen when once you add the chlorine into the water body in the stage number 1? In the stage number 1, what will happen? Chlorine is going to be reacted with the chlorine is going to be reacted with the inorganic impurities and they get oxidized. Inorganic impurities and they get oxidized, and once the oxidation of inorganic impurities is over, then further addition a further addition of chlorine is going to be observed in the stage number 2. For example, if you applied the dose of 5 milligram per liter, if you apply the dose of 5 milligram per liter, out of that, out of that 0.1 is going to be utilized for 0.1 milligram per liter dose is going to be utilized for oxidation of inorganic impurities, or 0.1 is utilized for the stage number 1. Stage number 1 means what? What is stage number 1?
Oxidation
Of inorganic impurities. Oxidation of inorganic impurities like Fe, sulfide, nitrates, that is going to be oxidized in the stage number 1. Okay, means in the stage number 1, the oxidation of inorganic impurities takes place. Agree? Now out of the 5, 0.1 get utilized. Now how much remaining? 0.5 मधले 0.1 गेले तर राहिले किती?
0.4.
So the 0.4 is now available. Now what that this point 4, what will happen? This point 4 reacted with the organic species. The point means what? In the stage number 2, what will happen? Now chlorine is reacting with chlorine is reacted with organic compounds, ammonia and amines. Chlorine reacted with organic compounds, ammonia and amine to produce chloroorganic species. To produce chloroorganic species and chloroamines. Chlorine reacted with the chlorine compounds, ammonia and amines to produce chloroorganic species and chloroamines. That is the point, and that is occur in the stage number 2. Here stage number 2, that is going to be occur. And at the point B, what will happen? Because of this chloroorganic species and chloroamines, the taste and odor of taste of the water is going to be objectionable. The odor is going to produce because some gases are going to be involved. So at stage number at point B, you observe the the taste and bad odor is going to taste, and we can say, see, bad taste and odor is going to bad taste and odor is observed at point B. So further addition after the point 5 also, if you add the chlorine 0.7, if you add the chlorine 0.7, the 0.7 out of the 0.7, 0.1 is going to be consumed for the stage 1. Agree? Yes or no?
Yes, sir.
Remaining up to the 0.5 means what? This much amount of chlorine is going to be consumed for the stage 2. Is it okay? This much amount of chlorine, this much amount of see, this much amount of chlorine is utilized for stage 2. First stage la 0.1, remaining la 0.2 la जो dark केलेला blue color चा, that is going to be utilized for stage 2. Is it okay? And after that, this is going to be left. This is going to remain amount of chlorine in the water body. Yes and no? This is going to remain here. बरोबर आहे. हा ग्रीन मधला काय रिमेन येतं पाण्यामध्ये, किती राहिलाय? 0.5 minus 0.7 किती राहिला?
0.2.
0.2. Now 0.2 is not available. What will happen? This 0.2 milligram per liter, that is going to be oxidation of this chloroorganic species, destruction of chloroorganic species and chloroorganic compounds. As a result of that, what will happen? The bad taste and odor is going to be removed at point C. At point C, if you observe, means what? The bad taste and odor is going to be removed, and this is going to be happen in the stage number 3. In the stage number 3, what will happen? The oxidation of chloroorganic species and chloroamines form. Oxidation of chloroorganic species and chloroamines form, and point C is accomplished by free of bad taste and odor. Free of bad taste and odor. Understand? Yes and no? Free of bad taste and odor. That is the point C. Understood? Yes and no?
Yes, sir.
Okay. Now, after 0.7, if you add further chlorine, that further chlorine is going to be act as a free residual chlorine. This is going to be act as a free residual chlorine. Means what? See, this is the straight line. This is straight line, and this one is curve. This is your straight line. Is it okay? Means what? After the point C, whatever the chlorine we are adding, that is going to be act as a free residual chlorine. Okay. In the water body, already combined residual chlorine is there, but after the point C, whatever the chlorine we are adding after the 0.7, if you add 2 milligram 0.2, that 0.2 is going to be act as a free residue. So the free residual chlorine is more effective than combined residual chlorine. One point, another point to remember here. Just जैसे HOCl is more effective than OCl, same thing is what here. Free residual chlorine is more effective than combined residual chlorine. Free residual chlorine is more effective than combined residual chlorine. Free residual chlorine is more effective than combined residual chlorine. Understood? Yes and no? So our aim is to what? you have to maintain the maximum free residual chlorine into the water body, so that the more disinfection is going to be possible. So this way this graph is going to work. I will show some video. From that also you can understand more. Now how many stages are here? How
4.
many stages? 4. Stage 1, stage 2, stage 3, stage 4. The different 4 stages are there, and the 4 stages are working on their what will happen in stage number 1, what will happen in stage number 2, 3, 4. Okay, this way all things are mentioned here. So I will show one video to you, so for more understanding. For more understanding, I will show video. See, first we see effect of pH, how the effect of pH works. Is it audible? Is it visible?
At the bottom of the graph,
Yes, sir.
Audible?
Yes, sir.
and on both sides, we have percent of hypochlorous acid on the left and percent hypochlorite on the right. And then we have these two lines in the middle to represent temperature. Well, we're going to look at the 20 degrees Celsius temperature line. And we're going to see what happens when the pH of the water is 8. Now, a pH of 8 is typical for water systems. So at a pH of 8, we see that 20% of the chlorine is in the form of hypochlorous acid and 80% is in the form of hypochlorite. So what that tells us is that most of our chlorine is in the weaker form at a pH of 8. And again, a pH of 8 is typical of many distribution systems. They operate there for corrosion control purposes. As we lower the pH to 7, we can see a dramatic impact on the distribution of chlorine species. At a pH of 7, 70% of our chlorine is in the form of hypochlorous acid and only 30% is in the form of hypochlorite. And something worth remembering is that 5.5, at a pH of 5.5, 100% of your chlorine is in the form of hypochlorous acid. So as you lower your pH, you don't need to go beyond 5.5. Now, the problem with this is pH of 5.5 creates a corrosive water. So, like we said before, for corrosion control purposes, most systems will operate at a pH in the 8 range to prevent corrosion in the distribution system. However, for the initial contact time, many plants will reduce the pH in the chlorine contact basin to get a good inactivation of the bacteria, and then raise the pH prior to sending the water to the distribution system, again for corrosion control. So this demonstrates the effect of pH on that equilibrium between hypochlorous acid and hypochlorite.
See, this is regarding the hypochlorous acid and hypochlorite ions. Now, this is the next video regarding the disinfection. Visible? Visible, audible?
Yes, sir.
It's important for treatment plant operators to have a good understanding of breakpoint chlorination and other reactions that occur when chlorine is added to water for disinfection purposes. To understand how chlorine reacts when added to natural water sources for the purpose of disinfection, we should first consider how chlorine reacts in pure water. When pure chlorine is added to pure water, it reacts to form hypochlorous acid and hydrochloric acid. Hypochlorous acid is one of the two forms of chlorine in a free chlorine residual. And when the hypochlorous acid dissociates in water, it forms the other form of free chlorine, which is called the hypochlorite ion. This reaction goes both ways and is pH dependent. As pH is lowered, the equilibrium shifts, favoring the formation of hypochlorous acid, which, by the way, is about 100 times more effective as a disinfectant than the hypochlorite ion. Now, conversely, as pH increases, the equilibrium shifts the other way, favoring the formation of the hypochlorite ion. Since there are no impurities in pure water for chlorine to react with, we expect our measured chlorine residual to equal the amount of chlorine added. For example, if we add chlorine at a dose of 2 milligrams per liter, we would expect a 2 milligram per liter residual, which is in fact what we find. And this also holds true if we increase the chlorine added to 4 milligrams per liter. And I'm sure you're not surprised to find out that if we increase the dose to 6 milligrams per liter, our pure water residual is also 6 milligrams per liter. So there's a linear relationship or a direct relationship between the amount of chlorine added and the residual that remains in solution. And this residual is a free chlorine residual that's made up of hypochlorous acid and the hypochlorite ion, depending upon the pH. So depending upon the pH, there'll either be more hypochlorous acid or more hypochlorite. Well, that's a great theory, but what happens when we add this same chlorine to groundwater or surface water that has these impurities in them, such as iron, manganese, nitrite, or even ammonia, that's the result of decaying natural organic matter that's in the surface water source? Well, let's take a look and see. As we begin to add our chlorine, like we saw earlier on our breakpoint chlorination curve, between points 1 and 2, we have iron and manganese, nitrites, sulfides, and other reducing compounds, so we have no residual. Once that demand has been met and we continue adding chlorine, it's going to react with the natural organic matter and the ammonia in the water between points 2 and 3 and form that combined chlorine, which is for the most part monochloramine. And that's formed between points 2 and 3 on our breakpoint curve. Also, between points 2 and 3, this is where trihalomethanes are formed due to the reaction between chlorine and the natural organic matter in the water. And at this peak, we have a chlorine to ammonia nitrogen ratio of 5:1. As we continue adding chlorine, there's a reaction between the chlorine and the ammonia and nitrogen, and it starts destroying that residual till it bottoms out at point 4, which is what we call breakpoint. At the breakpoint, we've reduced the chlorine residual as far as it's going to go, and now as we continue to add chlorine, we're going to see a linear response or a linear increase in the chlorine residual. And it'll be in the form of free chlorine. However, there remains combined chlorine with the free chlorine residual. And as we said earlier, 85 to 90% of the total chlorine residual will be in the form of free chlorine beyond breakpoint. Now, the form of that chlorine will either be hypochlorous acid or hypochlorite, and that's a pH-dependent reaction.
So I think most of you understand what we discuss right now. That is already here. So most of you understand what will happen when the chlorine is going to be added into the water body.